Okay, so now that you know the ins and outs of an atom, let's talk a little bit about some different forms that those atoms can come in that we're going to call isotopes. An isotope, these are atoms of the same element that have different numbers of neutrons. So it's still the same element. An atom of carbon is still carbon, but the neutron number is going to be different. So for example, down here with boron, you can see that the number of neutrons is going to be different based on the mass number given. However, that atomic number does not change because that atomic number still is used to identify the element. So the symbols are shown here. We can show just the element symbol with the mass on top and the atomic number on the bottom. And then the isotopes, we can also name them how they are down here using the mass. So this isotope is boron 10, and this one is boron 11. So again, we can refer to them using their mass numbers. So 3 isotopes for carbon are carbon 12 with 6 neutrons, carbon 13 with 7 neutrons, and carbon 14 with 8 neutrons. Alright, so go ahead and pause here. This is your first review question. I want you to look at these options A through F and say which ones could be isotopes of copper and explain your reasoning. Okay, so with atomic mass for isotopes, there's something else that we can consider here. So of those isotopes for an atom, each of those will be found in a certain abundance or in a certain quantity in nature, and that we call the natural percent abundance for the isotope. So the average atomic mass of an element is the average of all of those masses for the isotopes of that element. And this is actually the mass that's shown on the periodic table. So the units for mass on the periodic table are AMU, which is it's atomic mass units. Okay, so atomic mass units, and that's the average of all of the atomic masses for those isotopes. So something you can conclude from this is that the most abundant isotope you'll find will be closest to that mass you find on the periodic table, because since it's found in the greatest amount, that'll be the most mass that goes into calculating the average. Alright, so let's look at an example for that. So here we have carbon 12 and carbon 14, their percent abundance respectively, and then also the atomic mass. So up here, this is the equation that you can use to calculate this average atomic mass. So take mass 1, which would be 12, multiply it by this percent 1, and then add that to the second atomic mass multiplied by the second percent abundance. So it would have this set up here, and you have to take the percentages out of percent and into decimal. And your average atomic mass for carbon is 12.011 AMU. And this is the mass that you see on the periodic table. And you can also see it's closest to the mass of carbon 12 because that is the most abundant isotope. Alright, so here's your last review question. Neon's atomic mass, its average, is 20.1797. So without knowing the different isotopes of neon, what could you assume would be the most abundant isotope? So you want to give its atomic mass, and then explain how you would know this. Alright, and that's it for isotopes for now.